Good evening, guys. Okay, so in previous lecture, that is revision lecture for first unit, we have studied about 3 to 4 fluid properties like density, relative density, then specific weight, then capillary, your viscosity, means dynamic viscosity concept and kinematic viscosity concept. Now we will see our next property, which is surface tension. Okay, so as you know that it is often observed that a drop of blood, it will form a hump on a horizontal glass. As well, you observed that a drop of mercury forms a near perfect sphere and it can be rolled just like a steel ball over a smooth surface. As also you have observed about the water droplet from the rain or dew hang from the leaves of water. As here you can see that this water droplet from the rain or dew, it will hang from the leaves of the trees. Okay, in these and other observations, the liquid droplets behave like small balloons filled with the liquid. Okay, so this liquid droplet will behave like a small balloon which is filled with the liquid, and the surface of that liquid, okay, surface of that liquid acts like stretched elastic membrane under the tension, and the pulling effect force that causes this tension acts parallel to the surface, which causes this tension which acts parallel to the surface, and it is due to the attractive forces between the molecules, okay, of the liquid, and the magnitude of this force per unit length is nothing but your surface tension. So you observe that the water droplet will hang from the leaves. So why these observations will occur? Because the liquid droplets behave like a small membrane or small balloon which is filled with a liquid, and the surface of this liquid, it will act like a elastic membrane due to the surface tension. Okay, so we will see the property like surface tension. So what do we mean by surface tension? So surface tension is nothing but, or it is defined as the tension of the surface film of a liquid which is caused by the attraction of the particles in the surface layer by the bulk of the liquid, and which tends to minimize the surface area. Okay, here the main concept is to minimize, or it will minimize, surface tension will minimize the surface area. Okay, so actually you have observed that some insects, they can land on water or even walk on the water, and that small a steel needle can float on the water. These phenomena are made possible by the surface tension. Okay, because the surface tension will balance the weight of these objects. Okay, so surface tension can be defined as the magnitude of force per unit length. Okay, so it is due to the phenomenon of the surface tension that the drop of water tends to assume a spherical shape. Okay, spherical shape to attain the minimum surface area. So why it will attain the spherical shape? Because in all types of shapes, means we consider the cube or rectangular shape or spherical shape, the spherical shape has minimum area. So that's why it will tends to form, or liquid droplet will form a spherical, or your mercury will form a spherical shape. Okay, so now next property is capillarity. So what do we mean by capillarity? So capillarity, it is the property actually. Okay, so capillarity is nothing but the phenomenon of rise or fall of the liquid surface. Okay, so rise or fall of the liquid surface in a small tube relative to the adjacent general level of the liquid when the tube is held vertically in the liquid. Okay, so rise or fall of the liquid level in the small vertical tube when we insert this small vertical tube in the liquid. Okay, so the rise of the liquid of the surface is called as capillary rise, and fall is called as the capillary diffraction. Okay, and it is expressed in the centimeter or mm of the liquid, and actually its value depends on the specific weight of the liquid, diameter of the tube, and surface tension of the liquid. So Capillary rise. Capillarity is nothing but the tendency of a liquid in a capillary tube or absorbent material to rise or fall as the result of the surface tension. So now adhesive force. Back actually the capillarity, the concept of the capillarity, it will depends on the two forces, adhesive forces and cohesive forces. Adhesive means the attraction between unlike substances such as water and glass, and cohesive means attraction between the surface substances. Molecular stickiness is called as the cohesion. So this is the formula or method that we have derived, this formula for capillary rise, which is nothing but H is equal to 2 times sigma S or gamma LA into cos theta, where sigma S or gamma LA is equal to surface tension per unit length, okay, divided by rho into G into R. R is the, where what is the R? Actually R is the radius of that tube. Okay, so this is how we have derived this formula to find out the capillary rise. Okay, so as in previous lecture we have discussed about, if this angle phi it is less than 90 degree, then liquid will wet the surface, means water will wet the glass surface, and if is this phi is greater than 90 degree, then liquid doesn't wet the surface, means mercury in this case will not wet the surface. So in this case you will get the capillary depression, and in case of water means if phi is less than 90 degree, then in this case you will get capillary rise. Now next is, okay, this is about the capillary rise and capillary drop. So in this case phi is greater than 90, phi is less than 90 degree, and in this case phi is the greater than 90 degree. Now this phi is nothing but, this is defined as the angle that the tangent to the liquid, means angle that tangent to the liquid surface to the point of contact, angle to the tangent to the this liquid surface and the point of contact. Okay, this angle is nothing but the phi. So this phi in case of water is less than 90 degree, but in case of mercury this phi is greater than 90 degree. So for water phi is less than 90 degree, for mercury phi is greater than 90 degree. So if phi is less than 90 degree, it means you will get capillary rise. If phi is greater than 90 degree, it means you will get capillary drop. Okay, now next is the vapor pressure. Now the vapor pressure is defined as the pressure exerted by a vapor. Okay, pressure exerted by vapor is nothing but the vapor pressure. Okay, and now vapor pressure is nothing but the tendency of particles to escape from the liquid or a solid. Okay, and at normal temperature the substance with a high vapor pressure is often referred as a volatile. Okay, this is the vapor pressure, this is applied by this liquid molecules. Okay, next is the compressibility. Now we, as you know that the compressibility factor, it is also known as the compression factor or gas deviation factor, and it is the ratio of the molar volume of the gas to the molar volume of an ideal gas. Okay, so this is about your compressibility, and it is, gases are therefore highly compressible because their particles can be forced back closer together. Okay, so this is the gas and this is the liquid. So why gases are highly compressible? Because their particles can be forced back closer together. Okay, now next is the next concept, or we will start our second chapter in first unit. This is about the pressure statics. So this is the second chapter in your first unit. So what do we mean by pressure? So actually forces applied by fluid at rest or in rigid body motion, and this fluid property, as you know that the forces applied by the fluids which are at rest as well as in rigid body motion. Now the fluid property which is responsible for those forces is pressure. Okay, the fluid properties which is responsible for those forces is pressure, which is the normal force exerted by a fluid per unit area. Okay, so the pressure is nothing but, or it is defined as the normal force exerted by a fluid per unit area when we deal with a gas or liquid. Now in this chapter we will discuss the concept of pressure, absolute and gauge pressure, then the pressure at point, then variation of pressure with depth, Then the various pressure measurement devices like manometer. Then we will see the concept of hydrostatic forces applied by fluids. Then buoyancy, then stability of floating bodies, and analysis of the rigid body motion of the fluids in the container during the linear acceleration or motion. Okay, so first we will deal with the pressure. So fluid pressure. Okay, so as we know that the pressure is defined as the normal force exerted by a fluid per unit area when we deal with the gas or liquid. Okay, so now the fluid pressure is nothing but, or from Pascal's law we have derived one derivation, that so from Pascal's law we have concluded that the pressure at a point in a fluid has the same magnitude in all directions first. Okay, and this results in applicable to fluids in motion as well as fluid at rest, since pressure is a scalar, not a vector. Okay, now this is the fluid pressure, that is the concept we have covered in pressure variation in a fluid at rest. Okay, so we have concluded from that we actually concluded that if we take a point above to be at the free surface of a liquid open to atmospheric, then the pressure at depth h below the free surface becomes P equal to P atmospheric plus the rho gh value, or the pressure head due to the unit volume of the liquid. Okay, so an easier equation to remember and apply the pressure difference between any 2 points in the same fluid under hydrostatic condition is that the pressure below is equal to pressure above plus rho g h, where h is the difference between these 2 points. Okay, so we have discussed, or we have derived, that the fluid whose density changes significantly with elevation, a relation for the variation of pressure with elevation can be obtained by dividing equation by delta z. Means pressure at a point is given equal to pressure below is equal to pressure above plus rho g into h. Okay, so this is the pressure, fluid pressure. So fluid pressure is the pressure exerted by a static fluid depends only on the depth of the fluid. Okay, so it will depends only on depth, whether that it will depends on the depth, means h, the density of the fluid, and the acceleration due to gravity. So most remarkable thing about this expression is what it does not include the fluid pressure at a given depth does not depend on the total mass or total volume of the fluid or liquid. Actually it will depends only on the height, okay, then density and acceleration due to gravity. So it is, because its formula is nothing but pressure is equal to rho into g into h. Now rho g is nothing but the specific weight, or you can write it as gamma times h. Okay, so this is about fluid pressure. Now this is the pressure definition, as we have actually discussed the pressure definition as this is the normal force exerted by a fluid per unit area. So here it is given as the action of one force against another over a surface, and the pressure P of the force F is distributed over an area is defined as P is equal to force per unit area. Now what is the basic difference between pressure and stress, as we have discussed in earlier lectures? So stress is nothing but the internal resistance offered by a material against externally applied force, and pressure is nothing but the normal force per unit area. Now the units of the pressure. So first MKS system unit is Newton per meter square, which is also called as Pascal. Okay, on CJ system, instead of Newton we can write it as a kg per kilogram force per. Okay, what is mean by Newton? Newton is nothing but 1 kg meter per second square divided by centimeter square. Okay, and in English it is PSI. PSI is nothing but pascals per square inch. Okay, so this is about your pressure head. Now next, pressure head, it is nothing but the internal energy of a fluid due to pressure exerted on its container. So pressure head is nothing but the pressure between points divided by rho times g. Rho g means this rho gh divided by rho g. So you will get h. H is nothing but the pressure head. Okay. So this is the pressure intensity. How we are going to measure the pressure intensity. So pressure intensity is nothing but it can be, or its units are given in kg per centimeter square or psi. Actually you have observed that your tire pressure is measured in terms of kg per centimeter square or psi. Psi means pounds per square inch. Okay, and we have actually converted these all units in your lectures or in your theory lectures. So pressure intensity is a qualitative measurement. Okay, in particular flow of air, the pressure intensity might be high, while the total pressure is the pressure total would exist when that flow is brought to complete stop. Okay, now the next thing is the absolute pressure, gauge pressure, and vacuum pressure. Okay, so we will see the concept of absolute pressure, gauge pressure, and vacuum pressure. Now, as we know that the absolute pressure, the difference between the, as we have actually studied what is the basic difference between absolute pressure, gauge pressure, and your vacuum pressure. So we will see it in this lecture. Absolute pressure. So absolute pressure is nothing but the actual pressure at a given point. It is called as the absolute pressure. Okay, absolute means the actual pressure. Gauge pressure means it is above the atmospheric pressure. So gauge pressure will become absolute pressure plus atmospheric pressure. Okay, so the most pressure measuring devices are calibrated to read zero in the atmosphere, because we consider atmospheric pressure to be calibrated to read to zero. Okay, so most pressure measuring devices are calibrated to read zero in the atmosphere, and therefore they indicate the gauge pressure. So gauge pressure will become absolute pressure minus atmospheric pressure, but absolute pressure will become the gauge pressure plus atmospheric pressure. So absolute pressure, it means what? Above atmospheric pressure. Gauge pressure is what? So pressure below atmospheric pressure is called as vacuum pressure. So P vacuum by P vacuum is equal to P atmospheric minus P absolute, as actually we have studied in your second or third lecture. So now the absolute pressure is the actual pressure given at a given position. Gauge pressure is the difference between the absolute pressure and local atmospheric pressure, and vacuum pressure is the difference between the atmospheric pressure and absolute pressure. Okay, now atmospheric pressure. Atmospheric pressure is nothing but, so what do we mean by atmospheric pressure? Okay, so atmospheric pressure, or you can say it as a standard pressure. So a standard pressure, actually it is nothing but atmospheric pressure at a location is simply the weight of air above that location per unit surface area. So as a frequently used pressure unit is the standard atmosphere, which is defined as the pressure produced by a column of mercury. Okay, pressure produced by a column of mercury 760 mm in height at 0 degree Celsius. So atmospheric pressure is defined as the force per unit area exerted against a surface by the weight of air column. So this is the weight of air column. This weight of air column will exert pressure on this surface. So atmospheric pressure will become the weight of the force exerted by this weight of air column on this surface area. Okay, so measuring the atmospheric pressure. Okay, actually the Italian scientist Torricelli, he was the first to conclusively prove that the atmospheric pressure can be measured by inverting a mercury filled tube. Okay, inverting a mercury filled tube into a mercury container which is open to the atmosphere. Okay, and from this we have concluded that the atmospheric pressure is nothing but the pressure produced by a column of mercury which is equal to 760 mm in height at 0 degree Celsius. And instead of mercury, if we use water, then the height of this water column will be equal to 10.3 meters. Okay, so and from this the unit mmHg is called as the torr. Okay, now we will see the pressure measurement devices. So pressure measuring devices are classified in two manner. First one is manometer, second one is mechanical gauges. Manometer means simple manometer, then U-tube manometer, then single column manometer, differential manometers, as we have studied during our experimental setups. Okay, and second category is mechanical gauges. First one is Bourdon groove and second one is pressure gauge. Okay, now we will see the definition of in definition. Actually, we have studied about this absolute pressure. This is referred to zero or absolute pressure. Gauge pressure is nothing but the difference between the absolute and your gauge atmospheric. Vacuum is nothing but difference between the atmospheric and absolute. Now the pressure measurement devices. Okay, pressure measurement, actually a number of measurement units are used for the pressure. These are follows. Okay, first one is pounds per square foot, PSF, or pounds per square inch, PSI. Okay, this is the general unit which is used to measure the tire pressure. Okay, next one is atmospheric, means 1 atmosphere. Third one is Pascal. 1 atmospheric is nothing but 1.01325 into 10 raised to power 5 pascals. Okay, next one is Pascal, newtons per meter square or kilopascal. Second one, then fourth one is torr. Torr is nothing but 1 mm of Hg. Then next one is bar. Bar is nothing but 100 kilopascals. Okay, then these are the various types of pressure measurement devices. First one is U-tube manometer, second one is reservoir manometer, third one is inclined manometer, and this is mercury float manometer. Actually, we have studied these all instruments in our practical setup. Okay, these are the pressure gauges that this is first one is manometer, second one is this is reservoir manometer, third one is inclined U-tube manometer, and also we have studied about the differential U-tube manometer also. Okay, so manometer is nothing but with both legs of a U-tube manometer opens to atmospheric or subjected to the same pressure. The liquid maintains the same level in each leg, establishing a zero reference. If we attach our pressure measurement reservoir to this end, it will exert pressure from this by this liquid to this column. Then this column will rise up to this some height, and from this we will calculate the pressure of this gas or of this liquid. Okay, then similar concept we will apply. Instead of this, we will here directly connect our U-tube to the reservoir. Okay, so in this way we have studied our pressure measurement or pressure measurement devices. Okay, so this is about your pressure measurement and pressure measuring devices, as well as we have solved some examples based on this U-tube, inclined and differential manometer. Okay, differential manometer. So differential manometer, actually differential manometer, it is used to measure the pressure drop across the section, means pressure drop between the 2 points. We use differential U-tube manometer. Okay, so in this way we have revised our first unit, in which first chapter was properties of fluid and second chapter was pressure and its measurement. Okay, thank you.